Assalamualaikum and a very good day to you all. In this video, I would like to discuss with you the introduction of polynomials. So, polynomials, the word poly in front of polynomials it means many, okay? While nomials, the second part of the word is terms, terms of things. So, basically, polynomials means many terms, okay? And then polynomials must be like below, okay? So polynomial in the form of x plus a to the power of n to the power of something. So when we expand them from here, we expand them, then we get something like this lah, this long list of them. So what's the condition? There must be some condition for polynomials, okay? First is the n. The n must be 1, 2, 3 and so on. Okay? So by saying that cannot be 0, something negative, or fraction. Okay? And n is also the degree of px, the polynomial that we are having. Okay, so the long polynomial down there is the expansion of the bracket above here. So what we have here is a sub 1 x sub 1 to the power of n plus a sub 2 x sub 2 to the power of n minus 1 and so on until at the end. Okay, from this list, what we have is the constant here. Okay, not maybe I just the constants here. Got constant, right? All a's. Okay, so all these what we call constant terms. Okay, constant terms or coefficient lah. Okay, and there's something special about the first term over here. This one, particularly this one, because of the power of n here. This is also what we call the leading coefficient. The leading coefficient. Why it is a leading coefficient? Because the n is highest. Okay, inside the polynomial. Okay, so if the power of x is highest, then the coefficient of the power of x is the leading coefficient. Leading coefficient doesn't mean the very first term that we see inside the polynomial. It is the coefficient of x that has the highest power. Okay, for example, I show you here. Px equals x plus x squared, and another px x power 3 minus 2x plus 4. Okay, in this case, this is not the leading coefficient. The one in front of x is not the leading coefficient. The leading coefficient for the first px is 1 because 2 is the highest power for this px. While for the second example, since x to the power of 3 is the highest power inside this polynomial, so the leading coefficient is 1. Okay, so that's the example lah. Okay, so from there, okay, next. So let's detect which one is which, whether each one of them is polynomial or not. Okay, so let's have a look. Px equals 2x plus 3x squared plus 3 minus 3. So from here, as I said just now, this is clearly not the leading coefficient. Okay, this is the leading coefficient. But before that, let's see whether it's a polynomial or not. So from here, we know this is power 1, this is power 2, this is power 0. So the numbers are good. So Px is a polynomial. Okay, because why? Because the powers, the numbers of the powers are nice. Okay, next qx. Let's have a look. Power of 4, power of 2, power of minus 2. Something wrong, something off lah. Because it's a negative, so cannot consider qx as a polynomial. So qx is not a polynomial. Okay, now let's have a look at the next one. We have x and y. X squared, y power 1, y power 2, y power 3. So Rx is a polynomial, but not in our syllabus. I mean, our syllabus for our level for AM015. Okay, not in AM015, not in matriculation syllabus. Okay, let's continue. Now, we can add them, we can subtract them, we can multiply. Okay, even though very rare lah in the question, won't ask you to expand them because polynomial, it's many already. So if you expand them, for example, something power 3, so many multiple terms inside it, isn't it? And then another maybe power 4. Okay, so it's a cumbersome for you to do that. Don't worry, the question won't ask. This is just the introduction. Okay, with one another lah. So let's say we have px is x squared plus 2x minus 2 and qx 2 minus x. So px plus 2qx is just just plus 2x, sorry. Okay, and then we expand them lah appropriately. Okay, plus 4 minus 2x, and then what's this? X squared, 2x minus 2x is 0, minus 2 plus 4 is plus 2. So this is the summation of them. Okay, next. So maybe I bring these two a little bit further way down. Okay, good. Now, qx is 2 minus x minus 3px minus 3px is x squared minus 2x minus 2. Okay, and then 2 minus x minus 3x squared plus 6x plus 6. Now what we have is minus 3x squared plus correct, plus 5x plus 8. Okay, now I know some of you, not some, all of you, okay, will suddenly make it positive. Okay, I want to tell you that this is wrong. Okay, you cannot change the negative willy-nilly like that. Okay, because this is it's considered a function. Okay, so this is not equal to 0. This is not equal to 0. This is equal to the expressions that we have up top, which is this whole thing. So if qx minus 3px, okay, if you multiply everything with minus 1, it means that you multiply the left hand side by minus 1 as well. Okay, so but if it's this case, then it is correct, but usually it is not. So better don't change lah. Okay, just leave it like that. Doesn't matter whether the x squared is negative or positive. Okay, just leave it as is. Okay, now next one is a multiple. So multiple lah. P is x squared minus 2x minus 2. Okay, and then multiple 2 minus x. Okay, and then okay, this one I bring up top again, a little bit further. Okay, now no need lah bracket. Okay, so x squared with 2, it's 2x squared. X squared with minus x is minus x cubed. Okay, and then minus 2x with 2 minus 4x minus 2x multiplied by minus x is plus 2x squared. And then the last one minus 2 is minus 4 minus 2 minus x plus 2x. Okay, and then we have 4x. Okay, sorry. We have a cube minus x cube plus 4x squared minus 2x and minus 4. So this is the multiplication, this is the subtraction, and this is the addition, summation. Okay, so just do it one by one. Okay, properly expand them. Okay, next. Just now in number 4, I said that we can add, subtract, and multiply. How about division? Okay, we can actually. Okay, we can divide them, but but when we need to divide them, we need to perform a long division. What does it mean by long division? It's more or less like what you have done in why I cannot padam here. Okay, this is just like how you divide 10 by 7 back in primary school. Okay, what does it mean by that? Let me show you. So 10 divided by 7. This is what you've done in primary. Now, what is our aim that we want to divide? When we divide something by something, it simply means that we do subtraction repeatedly. Okay, so we want to find how many 7 inside 10 that we want to minus from. Okay, so we start with the first digit, right? Back in primary, you start with 1. Okay, now how many 7 in 1? The answer is nothing, so cannot, so it's 0 lah. Okay, so 0 multiply 7 is 0 lah. Okay, so we minus, we get 1, and then we bring another number, 10. Okay, now how about 10? There is a 1/7 in 10. So we multiply by 7, we get 7. Okay, oh sorry. And then we minus, we get 3. Now, we can proceed the division and to get a decimal. But back in primary, you didn't learn about decimal yet. Okay, so we stop here. Why we stop here? Because 3 is already smaller than 7. So this is what I meant by long division, is how you get 10 over 7. Okay, you perform the division to get 10 over 7 is equal 1 plus 3 over 7. Or, for you to get 10 equals 7 multiplied by 1 plus 3. Okay, so I think that's all. I will continue about long division in another video. Okay, thank you for your time and attention. Assalamualaikum. Have a good day.